Hello children. So today in the sessions we're going to study the nomenclature of organic compounds. Organic compounds nomenclature is very important. Why? Because the number of organic compounds is very large, and if you take their common names, it is very difficult to remember. But if you remember through their one particular system or particular set of systems, then it is easy to remember their names, and that is applicable to all over the world. So here we have two type of system in which names are given. One is a trivial system and second is IUPAC system. So trivial system means you can give the names by a Latin or Greek root word. Okay, but IUPAC system, that is called International Union for Pure and Applied Chemistry, and under these systems it is a proper systematic system is there. Then under these systems we'll write the names in a proper manner. So we'll see this IUPAC system in details. Let us see some common systems, common names. So trivial system is one is formic acid. Formic acid SCOH. It is taken from the word formica, which is found in ant. Formica is found in the abdomen of ant. So from that ant, the name has been taken. Acetic acid. Acetic acid is called acetum. So this is called actually vinegar. Vinegar is a Latin word, and from this word is taken this acetic acid. Similarly, butyric acid, this is butyric acid, carboxylic acid. Butyrum is the Latin word. It is taken from the butter. Since it is found in butter, that's why it's called butyric acid. Valeric acid, you can see this is the structure, and it is found in herb called valerian. Caproic acid, it is found in capar, that is goat, that is the Latin word. Then next is stearic acid. This is the formula. This is stear means tallow, it's a Greek word. Similarly, oxalic acid, oxalis, it is a kind of plant. Malic acid, Pius malus, it is a fruit. Citrus acid is a fruit. Urea, uric acid, this is derived from their names urine. So from urine it is taken urea and uric acid. Similarly, methanol, it is found in wood. After destructive distillation of this wood, we get the methanol. Then next is Mars. Mars gas is called as methane. Mars is produced in marshy areas. So like this. So names are very difficult to remember. So if you take their common names. There are some complex names. So you see, it's very difficult to remember. Common names are penicillins, streptomycins, quinine, morphine, vitamin A, limonene, alpha-pinene, vanillin, flavoring agents. So can you see the IUPAC common names and complex names, common names? So they are very difficult to remember. So if you go through a system of nomenclature, then we can write their names or understand their names. IUPAC, this body, they formulated a set of rules for the systematic classification of organic compounds, and this rules is also revised from time to time. So we study the latest revised rule of a nomenclature given by IUPAC. So according to IUPAC, what did they say? They said that any organic compound that consists of these only set. One set is your root word, very important things. This is nothing but the continuous carbon chain, and after root word you have to use the 1 degree suffix or 2 degree suffix. 1 degree suffix can be ane, yne, diene, troine, and secondary suffix is your principal functional group. So I have already discussed in the previous session. Then primary prefix can be cyclo, bicyclo, spiro, iso, neo. So these are the primary suffix. Primary suffix means it is added before the root word, and primary 1 degree suffix is added after the root word. Then if secondary suffix is also there, so this is always added. They are normally substituents and secondary functional groups. Secondary functional earlier I have discussed, and this secondary functional group is written alphabetically ordered. Now let us use these all rules, how the rules are there for different organic compounds. First is alkanes, rules for nomenclature for alkane. Alkane, if alkane is unbranched, so for unbranched, so we have to use the ane as a 1 degree suffix, which after the root word. So one root word is this is 3 carbons, which is called as propane. Ane is root word. We have 1, 2, 3, 4, and 5. So there are 5 carbons. It is called as pentane. Here we have how many carbons? 1, 2, 3, 4. So there are 4 carbons. So it is called as butane. And here we have 1, 2, 3, 4, 5, and 6. So 6 carbon is called as hex. And you add the ane, it becomes hexane. So when alkane is unbranched, we write very simple way. But when it is branched, the names are little changed. Let us see how. Now this is branched chain. So in a branched chain, so we'll use the rule number 1, that is called longest chain rule. Longest chain rule means first you have to find the longest carbon. So count carbon 1, 2, 3 and 4. Here also 1, 2, 3. So there are 3 carbon in this row and 1, 2, 3, 4, 1, 2, 3, 4, 4 carbon. So maximum 4 carbon you have to select. 3 carbon is the wrong answer. Here you count the carbon 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. So 5 carbon is the longest carbon, right? So you have to first select the longest carbon chain. Next is 1, 2, 3, 4, 5, okay. 1, 2, 3, 4, 5, 6, 7, okay. 1, 2, 3, 4, 5, 6, 7. So 7 carbon is the longest in this system. So this is the can be longest, or this can be longest. Anything can be longest, but 7 carbon is the longest chain. Here 1, 2, 3, 4, 5, okay. 1, 2, 3, 4, 5, 6. So 6 is the longest carbon. Here we can also count from this system 1, 2, 3, 4, 5 and 6. So anyhow 6 carbon is the longest chain for this system. So first rule number 1 is in branch alkane you have to select the longest carbon chain. That is a one chain rule. Now if two different chains of equal length, if chains are equal length, then chain with maximum number of side chains or alkyl groups is selected. This is very important. Let's see how. 1, 2, 3, 4, 5, 6, 7. So this is 7 carbon chain, and then let's count from this side. 1, 2, 3, 4, 5, 6, 7. Now you can see here we have also 7. 1, 2, 3, 4, 5, 6, 7 here also and here also. But if you count 7 here, so we have 1 and 2 alkyl groups. One here and one here. One is 3, one is 4. But if you take this longest chain, how many substituents are there or alkyl groups are there? So 1, 2, 3 and 4. So here we have 4 alkyl groups. Okay, and in that case it was how much? If you are selecting these groups, so we have 1 and 2 alkyl groups. But rule says that if you have 2 equal chains, what is that? Maximum number of side chains is selected. So this is wrong selection, this is right selection. Right selection means after selecting, this becomes 7 carbon chain, and this is the correct selection of longest chain. Now let us take one more example. So here we have, let us see, 1, 2, 3, 4, 5, 6, 7, right? And we have 1, 2, 3, 4, 5, 6. Or we can say 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. Now here you can also take it. 1, 2, 3, 4, 5, 6, 7. So if you count from this side, okay, you have chain 1, 2, and 3, right? But if you count from which side? From this side, the chain is 1, 2, 3, okay, and 4. So from this side, if you're counting, you have 4 alkyl groups, right? And when you are counting from this side, so you have 1, 2, and 3 alkyl groups. So definitely 3 alkyl groups is not selecting. 4 is correct answer, right? So I hope you have understood this important rules. Now let us see the position of substituent. This is the rule number 2, right? In position of substituents, so you have to find it. Now you have to select the longest carbon chain 1, 2, 3, and 4. 4 is the longest carbon, right? Now substituent is which carbon? From this side, it is your, suppose 1, 2, and 3, and 4. But if you count from this side, 1, 2, 3, and 4. So the position of substituent is 2 types. One is 3, one is 2. So which is more? So you have to use one more rule, that is called locate sum rule, right? The locate sum rule says that if substituents are there, you have to choose the that number, or if the substituents are more than 1, you have to add it, or you have to choose the lowest number of substituent, locant of substituent. So from this side it is 3, it is 2, so you have to choose the 2 is the correct one. So this side counting is correct, this side counting is wrong. Let us take here also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is there. Now if you count from this side, it is coming 3 and it's going 5. From this side it's coming 2, 3, and 4. So locant is 3 and 5. Here locant is 2 and 4. So sum is 2 and 4 is 6. Here 3 plus 5 is 8. So 8 is wrong, 6 is correct. So this side counting is correct. Let's count from this side. 1, 2, 3, 4, 5, 6. So here is 4 from this side, and 1, 2, 3, 4, 5, 6, right? So you have 2 type of counting is there. You can take anything. 1, 2, 3, 4, 5, 6. 6 is there. So anyhow, this is coming 3. So 4 is wrong, 3 is correct. Okay, so 3 is this side counting is only correct. This set counting is wrong. From here also, you see here, you can see 1, 2, 3, 4 and 5, right? And this is 5. Here is 1, 2, 3. So this is 2, 3 and 4. So 2 plus 3 plus 4, it is your how much? 4 plus 3 is 9. And here 3 plus 4 plus, definitely this set counting is wrong. This set counting is correct, right? From here counting is correct. Here counting is wrong. Now here. Now you can see very clearly this is the second substituent. So 1, 2, 3, 4, 5, 6, 7, 8. Means 2 plus 5 plus 6. So it becomes your 13. And if you take from this side, it is definitely longest. So count from this side correct. This side counting is wrong. Let's do the next side. So you can see this side is maximum number. So we have how many numbers? This is your, if you count from this side, is 2, 3, 4, 5. 5 is the two numbers, one here, one here. If you count from this side, 1, 2, 3, 4, 5, 6. So this side count is correct. So from 2, we have two type of groups. We use 2, 2. And then we have 5. So 2 plus 2, 4 and 4 plus 5, 9. So this is correct. So we have 2 to 5 is the name of the substituent. Now from this side, let's count out 1, 2, 3, 4, 5, 6 and 7. Same as counting is the highest. So we have to get the 7 number. This locate number is 1, 2, 3, 4. Right? If you come from this side, it is 1, 2, 3, 4. So both sides is correct. From here, we can take by seeing also 1, 2, 3, 4, 5, 6, 7, 8. This is only correct. The remaining is not correct. So our substituent will be 3 and 4. So this is only correct counting. If you take from this side, now this is very interesting question. 1, 2, 3, 4 and 5, right? And here this 2 carbon already here, 3, 4 and 5. So from 3 carbon we have 2 groups. From here 2 carbon is here and 3 this one. So we can say 3 plus 3 if you are taking this longest chain, right? And if you are taking this longest chain, so again we have same thing. So in the both cases answer is correct. So it is your actually 3 plus 3 dash 3 is the methyl groups. Now let us see next one more rule, that is rule number 3. So if there are 2 or more alkyl groups are present, suppose we have 2 or more alkyl groups are present, then use di, tri, tetra, or these alkyl groups you should use in alphabetical order. Let us see how. Now in this case longest carbon chain is this only. So alkyl groups are positioned here 2 and 3. So we write here 2, 3 dimethyl. Okay, 2, 3 dimethyl. Why dimethyl? Because this is methyl groups. So this is 2, 3 dimethyl. Next is this one. Let's see here. This locant is 2, this 3, 4 and 3 and 4. So 2 is methyl and 4 is ethyl. So we use 2 methyl and next is your 4 ethyl. So this is 2 ethyl, 2 methyl, 4 ethyl. Okay, like this is the order and alphabetical order. So methyl is written after ethyl. So we can write actually 4 dash ethyl comma 2 methyl. Why? Because you see alphabetically E will come first and will come later on. So this is correct. This is the wrong way of writing. So you should use the alphabetical order also. Let us see this one. So we have to start from here. This side is wrong. 1, 2, 3, 4 and 5. This is 2. This is 3. Now see here. This is methyl. This is methyl. This is ethyl. So definitely we should write here. This is 3. So first we write here 3 ethyl. And next is your 2 dash 3 dimethyl, right? Because why? Because E will alphabetically come before the M. So 3 ethyl, 2, 3 dimethyl. It's very easy. Now see this one. So 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 and 6. So we can see the 6 carbon chain is the longest. Or you can see 1, 2, 3, 4, 5 and 1, 2, 3, 4 and 5. And 1, 2, 3, 4, 5 and 6. 6 is there. So if you take 6, so this becomes your, it is your tertiary butyl and this is your methyl, right? This is methyl, this is tertiary butyl. So tertiary butyl means this is your tertiary, tertiary butyl, B-U-T-Y-L-E, and this is your methyl. Okay. So both are present in which carbon? So carbon number, this is 3 from here counting 1, 2, 3. So we can use B will come first. We will not use this prefix tertiary first. We will take B. This you have to remember. So it is actually 3 tertiary butyl, then comma alphabetically 3 methyl, right? So easy, you can just understand. It's very easy. Now let's take this one. 1, 2, 3, 4, 5, 6. 6 means already it is hexane. So we can say 1, 2 and 3. This is 4. So we can say 3, 4 diethyl. Why ethyl? Because this is CH2, CH3. This will give you C2H5. And you know the C2H5 common name is ethyl. So it is 3, 4 diethyl. Both are ethyl groups. Okay. So I hope you understood this rule number 3 also. Now we'll see the next nomenclature, naming of complex substituent. Now substituent is not simple like alkyl ethyl. It is something different from alkyl and ethyl. So there are two types of substituent. One is simple substituents, that is ethyl, methyl, alkyl groups, but this is your complex substituent. You can see on branching we have some further branching is there. So in that case, how we'll start it? So we can see 1, 2, 3, 4, 5, 6, 7, 8, and again count from this side 1, 2, 3, 4, 5. So anyway, it counting is same. So how to write this locant? It's very easy. This is your locant number 5. In 5, you have to nomenclature this substituent as a once more. So how to name? So if this 5 is there, so write here 5 first, and then dash. This is your 1 carbon, 2 carbon, 3 carbon. So 1 methyl, 2 methyl. So we can write here 1, 2 dimethyl, and this whole is propyl. 1, 2, 3, 3 is called as propyl, right? So this is your dimethyl propyl, and then next whole compound is your N is your called as nonane, right? So it is a 5-1,2 dimethyl propyl nonane, right? So let us see here in this complex substituents. So we have one is simple substituent, one is your complex. This complex substituents. So you have to remember this rule. So what is the rule? Says that in simple substituents, so we are using the multiplying prefix are not considered. What is multiplying prefix? Multiplying prefix means like di, tri, okay, tetra. These are multiplying prefix. So if the longest chain consists of only simple substituent, then we don't use the multiplying prefix. But if in complex substituent, suppose it is containing simple as well as complex, then multiplying prefix is considered. For which one? For complex one, while deciding the alphabetical order. So we have simple substituent and complex substituent. So in this case, we have to also consider the multiplying prefix. Here we will not consider. So let us check it. How to write this one? So first we count this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is there, right? So here is also. So we again, if complex is there, you have to start from this side, right? So this complex is given more priority. So if you see the locant by lowest sum rule, 1, 2, 3 is given ethyl, but that is wrong. This is complex compound, so we have to start from this side, not from this side. Okay. If you count from this side, 1, 2, 3, 4, 5, 6, and if you count from this side, it's coming 5 locant. So counting from this side is correct. You have to remember this rule also. So let's write number 1, 2, 3. Okay, so 3 means 2 we have dimethyl. So we write here 5 dash, and this becomes your 2, 2 dimethyl, and then next is propyl, and already we know ethyl. So this is your di and this is ethyl. So D is come alphabetically first. So we write dimethyl ethyl, and 10 is called as decane, right? So we write this is the nomenclature of this compound. Let us say this one. Now this is the complex, this is the simple. So okay, so counting from this side is not suitable. So you have to count from this side. So this side means cut this one. 1, 2, cut here. This becomes 3. This becomes 4. This becomes 5. This becomes 6, correct? This is 7, 8, 9, 10, and 11. 11 is undecane. Now how to write this name? So name will be 1, 2, and 3. So we have 1, 2 dimethyl propyl, right? So this is your 5. We can say 5 is outside. 5, 1, 2 dimethyl, right? And next is propyl, and after that this is your ethyl. Ethyl is 7th, so we can say comma 7th methyl, right? And you see the alphabetical D is coming first, then M. So here we will use the multiplying prefix, and last is undecane. Okay, I hope you have understood this one. Now this is both as complex substituents. In that case, you have considered 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. Both the way it is same. So first you write for this name. So the name of this substituent is 1, 2, 3 means 2 methyl propyl, and here is your 1, 2, 3 means this becomes your 2, 1, 1 dimethyl propyl. Okay, so let us write. So this is your 5-2-methyl propyl, right? And this is your 5-11 dimethyl, 1,1 dimethyl propyl, and this is your 1,2 methyl, and this becomes your propyl, right? Okay, this is a 2-methyl propyl, and this is a 5,1,1 dimethyl propyl. This is 1,1,1, 2 and 3, so 1,1 dimethyl propyl. Now how do you write the nomenclature? So nomenclature, you can see this is the M and this is your di, so this is given more priority. So actually it is 5,1,1 dimethyl propyl, and then next comma, this is your 2-methyl and next propyl. Okay, and after that the longest carbon chain, that is your 9, that is called nonene. Okay, so this is the way of writing. So you have to consider the multiplying factor in complex substituent also. Now let us say for this one, so this is a complex, so we can see it's very large complex, and in this case both substituents are almost same. So if the complex substituent both are same, so we use the terms bis, tris and tetra, just like this one. So let us write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And 12 is your so didecane or dodecane is there. So this is called as start from here 1, 2, 3 and 4. So this is your 5 and 6. So we can say this is your 1-methyl butyl. So it is your 1-methyl then this is your butyl, right? 1-methyl butyl, and how many butyls are there? This is your 5 and 6. 1-methyl butyl, 5 and 6, and last is dodecane. Okay, dodecane. And here if the if 2 and more complex substituents with lower locant is written first, lower locant. Okay, 2 or more. So here substituents are how much there? So this will be your 1, 2, 3 and 4. So 1 is your, you can see methyl, and this is butyl, right? 1-methyl butyl at carbon number, and here is we have 1, 2. So 3 and 4. So this will be your 2-methyl and butyl, right? So in this case, which is lower one? So lower one is 2-methyl butyl, and lower one is 1-methyl butyl. So this is written first. So we have to see 1, 2, 3, 4 and 5. So we use term 5, 1-methyl butyl, then 2-methyl butyl, and this is 6, 7, 8, 9 and 10, and then is your total is decane. So this is written first, then this one, and the last one is decane. So 1-methyl butyl, 2-methyl butyl at 6 carbon, and the last one is decane. So in this way we are writing the nomenclature of all these compounds.